The James Webb Telescope has been our eye in the sky, peering into the depths of space to bring the cosmos closer to home. Its lens has unraveled the impossible, pushing the boundaries of science. During one of its movements, the James Webb Telescope revealed an image of Proxima b, our closest exoplanet neighbor, captured in detail. But something unexpected happened. What could it be, and what mysteries does the James Webb Telescope have to solve? Stay with us as we unravel the story behind this image and the sudden silence of humanity's greatest space observatory, the James Webb Telescope. The James Webb Space Telescope, JWST, was specifically designed to revolutionize the field of infrared astronomy. Equipped with cutting-edge, high-resolution, and high-sensitivity instruments, it surpasses the capabilities of its predecessor, the Hubble Space Telescope, by enabling the observation of objects that were previously inaccessible due to their age, distance, or faintness. This groundbreaking capability opens up a vast array of research opportunities in various areas of astronomy and cosmology. Stay to the end to find out about these discoveries and how they affected the James Webb Telescope. Astronomers have made an incredible discovery and have identified what could potentially be 6 massive galaxies from the very early stages of the universe. These objects are so incredibly large that, if confirmed, they have the potential to completely revolutionize our understanding of how galaxies form and evolve. These findings, published in the prestigious journal Nature, utilize data gathered by the powerful James Webb Space Telescope's infrared sensing instruments to provide a glimpse of what the universe looked like a staggering 13.5 billion years ago when it was just a mere 3% of its current age. What is truly mind-boggling is that these potential galaxies, which may have existed only 500 to 700 million years after the Big Bang, already exhibited a level of maturity comparable to that of our own 13-billion-year-old Milky Way galaxy today. The sheer mass of stars contained within each of these objects is estimated to be several billion times greater than that of our Sun. According to the research conducted, one of these galaxies could potentially have a mass of stars equivalent to a staggering 100 billion times that of our Sun. To put this into perspective, our Milky Way galaxy contains a mass of stars roughly equivalent to about 60 billion suns. This discovery serves as a stark reminder of the immense scale and complexity of the universe, offering a tantalizing glimpse into the early stages of galactic evolution and challenging our preconceived notions of how galaxies come into being. The implications of this research are profound, and what happened next after its discovery with the James Webb Telescope is something that will shock you. Erica Nelson, an astrophysicist at the University of Colorado Boulder and a co-author of the study, expressed her surprise at the discovery of galaxies with as many stars as the Milky Way appearing so quickly. She highlighted the incredible nature of these findings. She found an exoplanet, a celestial body located outside of our solar system, discovered in the Centauri B star system. This exoplanet is an incredible 11 times more massive than Jupiter, the largest planet in our solar system. The Centauri B star system is classified as a young binary system, meaning that it consists of 2 stars orbiting around a common center of mass. This particular star system is located approximately 325 light-years away from Earth, making it quite a distance from our planet. Centauri B, which has recently been discovered, is one of the most massive planets ever identified. This planet orbits around 2 stars that are significantly heavier than our Sun, with a combined mass that is 6 to 10 times greater. This makes the Centauri system the most massive one in which a planet has been observed. Additionally, Centauri B is known to be the hottest star system that hosts a planet. The 2 Centauri B stars, also known as Centauri A and Centauri B, are relatively young in cosmic terms, being only around 15 million years old. In comparison, our Sun, a G-type main sequence star, has been shining for over 4.5 billion years, making it significantly more mature. Despite their youth, the Centauri stars have already gone through various stages of stellar evolution, shaping their characteristics and influencing their future development. The researchers were initially anticipating the discovery of small, young galaxies in the early stages of the universe's development. Ewan O'Neill, the lead researcher of the study from Swinburne University of Technology in Australia, described these galaxies as monsters that seem to have rapidly matured. The mystery of how these galaxies were able to reach such a level of maturity at such a fast pace remains unanswered, leaving scientists intrigued and eager to delve deeper into this phenomenon. They have discovered something more intriguing: Proxima Centauri near the Centauri B star. Proxima Centauri is a red dwarf star located just over 4 light-years away from Earth and is known for its frequent and intense flares of radiation. These powerful bursts of stellar energy have the potential to significantly impact the conditions on any planet orbiting the star. The radiation emitted during these flares could have a detrimental effect on the atmosphere and surface of Proxima Centauri b, potentially stripping away the protective layer of gases that allow life to thrive. The intense radiation from Proxima Centauri's flares could also pose a significant threat to any potential life forms that may exist on the planet. Exposing organisms to harmful levels of radiation could hinder their ability to survive and reproduce, making it challenging for complex life to evolve on Proxima Centauri b. Despite these challenges, the possibility of Proxima Centauri b hosting an environment conducive to life has captured the interest and excitement of scientists and astrobiologists alike. The potential for liquid water to exist on the planet, along with its location within the habitable zone of its star, makes Proxima Centauri a tantalizing target for further study. Using sophisticated computer models similar to those used to analyze climate change here on Earth, scientists have discovered that Proxima Centauri can maintain vast expanses of liquid water on its surface across various scenarios. This exciting development significantly bolsters the chances of the exoplanet being able to support diverse forms of life. Despite its proximity, scientists still know very little about Proxima Centauri's planetary companion. What is known is that the planet has a mass of at least 1.3 times that of Earth and orbits its parent star every 11 days. This lack of information presents a unique challenge for researchers eager to learn more about this intriguing celestial body. This leads us to a question: is the atmosphere in Proxima Centauri conducive to life? Proxima Centauri b, the exoplanet that orbits within its star's habitable zone, is positioned at an optimal distance from its parent star to receive sufficient starlight to maintain a surface temperature above the freezing point of water. This crucial placement within the habitable zone implies that there is potential for liquid water to exist on the planet's surface because, as we know it, water is a key factor in supporting life. However, it is noteworthy to mention that because of Proxima Centauri's orbit, which is close to its star, the planet may have become tidally locked. As a result of the intense gravitational forces at play, tidal locking means that one side of the planet always faces its star while the other remains in perpetual darkness, a phenomenon similar to the Moon's relationship with Earth, where only one side is visible from our vantage point. There are two likely scenarios for the atmosphere of Proxima Centauri b. In one case, it is possible that the planet's water condensed and the hydrogen was lost to space, resulting in only oxygen or carbon dioxide remaining in the atmosphere after the planet's early history. On the other hand, it is also possible that Proxima Centauri b had a primordial hydrogen atmosphere or formed farther away from its star, which would have limited the escape of water. This suggests that Proxima Centauri b may have retained its water beyond its early history. If indeed an atmosphere exists on the planet, it is likely to contain oxygen-bearing gases such as oxygen and carbon dioxide. When combined with the star's magnetic activity, these gases could lead to the formation of auroras that might be visible from Earth and make the planet look like it has a magnetic field. But that's not all. Climate models, including general circulation models used for Earth's climate, have been utilized to simulate the atmospheric properties of Proxima Centauri b. These models take into account factors such as whether the planet is tidally locked, the presence of water and carbon dioxide, and various other variables. Different scenarios are possible for the conditions on Proxima Centauri b. It could be a planet covered in ice, either partially or completely. Alternatively, it might be a large planet with vast oceans or smaller bodies of water. There is also the possibility of regions with only dry land. Some models even suggest the existence of unique features like eyeball-shaped or lobster-shaped areas with liquid water resembling claws sprouting from the equator. Moreover, scientists speculate about a subsurface ocean beneath a thin, slushy ice cover that may vary in thickness across different locations. By using climate models, scientists have been able to explore the potential conditions on Proxima Centauri b and consider the wide range of possibilities for this distant exoplanet. But then, is Proxima Centauri b habitable? Proxima Centauri b faces a challenge when it comes to its habitability due to the strong UV radiation and X-rays emitted by its star, Proxima Centauri. This planet receives much higher levels of radiation, especially X-rays, compared to Earth. In the past, it might have even received higher amounts, resulting in cumulative X-UV radiation that is 7 to 16 times greater than what Earth experiences. This radiation can cause the atmosphere to evaporate as hydrogen absorbs it and becomes trapped, eventually reaching a point where it can escape the planet's gravitational pull. While some models suggest that Proxima Centauri b could retain a significant portion of its water, or even possess a denser atmosphere than Earth, the possibility of water loss cannot be ruled out. Another critical aspect is whether the planet can shield itself from its star's harmful rays. On Earth, we rely on the magnetic field and atmosphere to protect us from ultraviolet and other harmful radiations. However, for Proxima Centauri b, the strong radiation might present a significant challenge to maintaining a habitable atmosphere. Nevertheless, even if the planet's atmosphere is substantially altered, it does not necessarily mean that life cannot exist there. Life might still find a way to thrive in such conditions, but it could take different forms and have unique adaptations to survive the intense radiation. The potential habitability of Proxima Centauri b remains an intriguing and complex topic for scientists to explore further. Given the existing limitations of current telescope technology, astronomers have been unable to conclusively determine whether Proxima Centauri b is habitable. However, several upcoming telescopes and space missions hold the promise of providing valuable insights into the composition of exoplanetary atmospheres. One such mission is NASA's James Webb Space Telescope, which launched in 2021. With its advanced capabilities, this space telescope can potentially determine the presence of atmospheres around rocky exoplanets within the habitable zones of M-dwarf stars like Proxima Centauri. By carefully observing the subtle signatures of starlight passing through exoplanetary atmospheres, scientists hope to identify crucial elements like oxygen, carbon dioxide, and methane, which are essential for assessing the potential habitability of these distant worlds. Through these upcoming missions and advancements in telescope technology, astronomers are eager to uncover more information about the possibility of life on planets like Proxima Centauri b and gain deeper insights into the mysteries of the universe. Through these upcoming missions and advancements in telescope technology, astronomers are eager to uncover more information about the possibility of life on planets like Proxima Centauri b and gain deeper insights into the mysteries of the universe.